Okay, guys, these are the answers to what we were doing in class on Tuesday that we ran out of time to go over. So, for number one, the idea was that no, S is not the same as S squared. You can see those in the pictures over here. So, whoops, I'm just trying to make my pen work, sorry. So, this over here is that first expression that is not looking at like the same picture as this. So very simply, something like S is not the same as S squared could be an example of how you could explain it. And some of this was done, and I'm going to fill in the rest that I didn't get to with my small group. So the number 3 was asking you to specifically use substitution. So we want to see any number really besides 0 and 1. So if I chose the number 2, I would do 2 times 2 squared. Sorry, 2 times 2 is that 2s plus 3 times 2, here's the squared. And then that math would be 3 times 4, which is that 12. And I know this might not have matched your number if you picked something other than 2, but I'm getting 16. And then I have to do the same thing. Don't forget about that 5s, or 5 times 2, which is 10. And 10 is not the same as 16. So that could have been one possibility. Again, you could have picked a different number to substitute in. But number 4 is not asking you to substitute. It's asking you to use the property, the distributive property. So you can see how I rewrote this 2s plus 3s squared to be 2 times s plus 3 times s. I got rid of this common factor of s and I put it on the outside, and then everything that was left in those parentheses I stuck in the side, the pink parentheses, which is now blue. So we should have an expression here of s on the outside with 2 plus 3s on the inside. So that is one answer that you should have matched up with mine. Number 5 was asking you to draw math tiles, and I know that I've been modeling this along the way. I know that the s squared is that blue square. So you see on one side, the s squared plus 2s squared is here. And then the 3s squared is over here with pictures. And so, yes, they both have 3 square tiles. So, yes, they are equivalent. And you can see me plucking and plopping a 10 in below. Again, you might not have 10 as your substitution number. So your answers might not match here. But it's the idea that whatever numbers you picked did actually match at the end. And you can see my 300 is matching up to prove that they are, in fact, the same expressions. Number 6 was a challenge, and when I started talking about this with one of my groups, I didn't get a chance to finish, and the hard part was that you don't have to use each term. You have to use each term once, but you can use some of them for one expression and then some of the others for the equivalent expression. So this took a little bit of trial and error. But one possibility, and there could be more, is to use the 12a, okay, and the 24, because these two have a common factor of a 6. And if you were to pull a 6 out, you would be left with the 2a, which is this, and then the 4. So this is one possibility, not saying it's the only. And then proving that they are equivalent, you can show that distributive property here. And 6 times 2a is that 12a. And then 6 times 4 is that 24. Again, proving could mean use the distributive property, or proving could mean use that substitution. And when you substitute in a number and then do the math, you should get 2 equal answers. So that one was the hardest. Number 7 was asking you to explain what Bethany did wrong. And so what she did not do is she did not substitute 2 for the third term, x, in 3x plus 6 plus x. So you can see that um, is going to be her error. Substitute 2. So if x is 2, here's an x, you need a 2. And then here's an x, and you see that there's no 2 here. Okay, and so that's why she's getting the same answer, and she shouldn't have. So again, those are the answers. Hopefully that makes this practice kind of feel more wrapped up. I know we ran out of time in the class, so hopefully this video will help that. And I will see you in class Thursday for some more practice. Bye.